nature of root. Ax square plus bx plus c equal to 0. Nature of root means value of roots are real, imaginary, equal or unequal. This is called the nature of roots. Here x is equal to minus b plus minus root over of b square minus 4ac divided by 2. Nature of root will depend upon value of b square minus 4ac. Case 1. When b is greater than 0. This term is known as discriminant. b is equal to b square minus 4ac. This term is known as discriminant. b is equal to b square minus 4ac. When b is greater than 0, means b square minus 4ac is greater than 0. Let b square minus 4ac is equal to 5. So x is equal to minus b plus minus root 5 by 2a. So one value will be minus b plus root 5 by 2a. And second value will be minus b minus root 5 by 2. So these terms will be unequal and real. So when b is greater than 0, roots will be real and unequal. When b is greater than 0, roots real and unequal. Roots real means it will cut x-axis. Any graph will cut x-axis. That means that graph will contain real roots. Roots real and unequal. Unequal here are two roots. So graph will cut x-axis at 2 times. Case second, when b equal to 0. b equal to 0 means b square minus 4ac is equal to 0. Means x is equal to minus b by 2a. Means alpha is equal to beta is equal to minus b by 2a. So two roots and both are equal and real. So when b is equal to 0, then roots are real and equal. Real and equal means it will not cut x-axis but it will touch x-axis. Case 3, when b is less than 0, b is less than 0, let b is equal to minus 5. So x is equal to minus b plus minus root minus 5 by 2a. So minus b plus minus I root 5 by 2a. I means root minus 1 is equal to I. So here alpha and beta roots of equation will be imaginary, but these two roots are still unequal. One root is minus b plus I root 5 by 2a and other root is minus b minus I root 5 by 2a. So when b is less than 0, roots will be imaginary and unequal. So roots will be imaginary means graph will not cut x-axis at any point. Neither it will touch nor cut x-axis at any point. So these three are basic cases. When b is greater than 0, roots real and unequal. When b equal to 0, roots real and equal. When b is less than 0 means roots complex and unequal. Now let's move to graph of these functions. Y is equal to ax square plus bx plus. So y is equal to a x square plus b by ax plus c by a. So y is equal to a x square plus b by ax plus b square by 4a square minus b square by 4a square plus c by a. So y is equal to a x plus b by 2a whole square minus b square minus 4ac divided by 4a square. Means y is equal to a x plus b by 2a whole square minus b by 4a. So y plus b by 4a is equal to a x plus b by 2a whole. Let y plus b by 4a is equal to capital Y and x plus b by 2a is equal to capital X. So y is equal to ax square. This equation is known as equation of parabola. Equation of parabola opening upwards or downwards, this will depend upon the value upon A. A is positive, then graph will opening upwards, and when A is negative, graph will opening downwards. Like when A is greater than 0, graph will be like this, and when A is less than 0, graph will be like this. A is greater than 0, graph will be opening upwards, when A is less than 0, graph will be opening downwards. Okay. In this center point is 0, 0, this graph will contain like this. But in this case, we shifted 0 to minus b by 4a, and here 0 to minus b by 2a. So their center will be, their minimum point will be minus b by 2a, minus b by 4a. Here y plus b by 4a is equal to ax plus b by 2a whole. Okay. Now different cases will arise. Case when a is greater than 0. A is greater than 0. Case 1 when b is greater than 0. A is greater than 0 and b is greater than 0. B is greater than 0 means graph will cut x-axis at 2 points. A is greater than 0 means graph will be opening upwards. So graph will be like this, opening upward, and it will cut x-axis at 2 points, alpha, beta. Now here check. This is x-axis, this is y-axis. Y-axis means graph of value of fx, and this is value of x. When x is less than alpha, when x is less than alpha means this area. When x is less than alpha, value of function is positive. Fx is positive. When x is greater than beta, value of fx is still positive. When x is in between alpha and beta, then fx is less than 0. So when value of x is less than alpha, fx is greater than 0, value of x is greater than beta, then fx is greater than 0, and value of x is in between alpha and beta, then fx is less than 0. So we can't predict the value of fx in case of b is greater than 0. It will depend on the value of x. When x is less than alpha, fx will be positive. When x is greater than beta, fx will be positive. But when x is in between alpha and beta, then fx will be negative. So this will depend upon the value of x. When b is greater than 0 and a is greater than 0, graph will be opening upwards, and it will cut x-axis at 2 points. Okay. This point will be minus b by 2a, minus b by 4a. Minus b by 2a and minus b by 4a. Minimum value of this graph will be minus b by 4a. At which x? At x is equal to minus b by 2a. And maximum value will be infinity. This graph will tend towards infinity at x is equal to infinity. So in this case, fx minimum will be minus b by 4a at x is equal to minus b by 2. Fx minimum will be minus b by 4a at x is equal to minus b by 2a. Like we want to find the minimum value of x square plus x minus 1. We want to find the minimum value of this. Minimum value will be minus b by 4a minus b square minus 4ac divided by 4a means minus 1 minus plus 4 divided by 4 means minus 5 by 4. Minimum value of this function will be minus 5 by 4 at which x? At x is equal to minus b by 2 means minus 1 by 2. At x is equal to minus 1 by 2, this value will be minus 5 by 4. Minimum value will be minus 5 by 4 at x is equal to minus 1 by 2, and maximum value will be infinity. Any quadratic, cubic or 4-degree equation has maximum value will be always infinity at x is equal to infinity. Okay. This is case 1 when a is greater than 0 and b is greater than 0. A is greater than 0 and b equal to 0. B equal to 0 means graph will touch x-axis and opening upward. This point is minus b by 2a, 0. When x is less than this point, when this is find alpha comma 0, alpha is equal to minus b by 2a. When x is less than alpha, function value will be greater than 0. Fx is greater than 0. When x is greater than alpha, still fx is greater than 0. When x is equal to alpha, then fx will be equal to 0. So we still can't predict the value of fx in case of b equal to 0. Because when x is less than alpha, fx will be greater than 0. When x is greater than alpha, fx will be greater than 0. When x is equal to alpha, then fx will be 0. So minimum value of this function will be 0 at which x? At x is equal to minus b by 2a, and maximum value will be infinity. Like case x square plus 4x plus 4. So x plus 2 whole square, and any whole square will minimum value of any whole square will be 0. So minimum value of this function will be 0 and maximum value will be infinity. At which x? At x is equal to minus b by 2a, and minus at x is equal to minus 4 by 2. Means at x is equal to minus 2, this value will be 0. Minimum value will be 0 and maximum will be infinity. Case third, when a is greater than 0 and b is less than 0. b is less than 0 means graph will not cut x-axis. Graph will not cut x-axis, it will go like this. Means for any x, fx will be greater than 0. For any x. For any x, fx will be greater than 0. Means when t is less than 0, then fx will be greater than 0. Means discriminant of any function, any equation is less than 0, then fx, that function will always be positive. Like x square plus x plus 1. Here b is equal to b square minus 4ac means 1 minus 4 means minus 2. b is equal to minus b means b is less than 0. So this value will always be greater than 0 for any real value of x. Put x is equal to minus 3, minus 4, 2, 0, 1, any value of x, this value will be greater than 0. Okay? For any value of x, minimum will be still minus b by 2a, minus b by 4a. This minus b by 4a will become positive by b is less than 0, so this will become positive and a is already positive, so positive by positive is equal to positive. So this will be positive. Okay, minimum value will be positive and this value also will become. Now when a is less than 0, a is less than 0, we simply like minus 2x square plus 3x plus 3. So take minus common, 2x square minus 3x plus minus 2. Now deal this like a is greater than 0 and just multiply with minus 1. So no need to go through this a is less than 0 very precisely. Case when b is greater than 0. b is greater than 0 and a is less than 0 means opening downward. Opening downward means this value. This is alpha, this is beta. Now when x is less than alpha, then function's value will be x is less than alpha. Then fx will be less than 0. When x is greater than beta, then also fx will be less than 0. When x is in between alpha and beta, then fx will be greater than 0. Okay. Then fx will be greater. This is just reverse of that first case. When a is greater than 0, then x is less than alpha, fx is less than alpha, and in that case when a is greater than 0, x is less than alpha, and fx will be greater than 0. So just reverse of that case. When b equal to 0 in this case, b equal to 0 means it will touch x-axis. Then same, when x is less than alpha, then fx will be less than 0. When x is greater than alpha, then also fx is less than 0. When x is equal to alpha, then fx will be 0. Okay? Now third case, when d is less than 0, d is less than 0, it will not cut x-axis. Then for all values of x, fx will be less than 0. Okay? So these are basic graphs of quadrilateral. Now some conditions are there like find case 1. Find condition when a number k lies between two roots of ax square plus bx plus c equal to 6. We want to find the condition when a number k lies between two roots of equation. This root is alpha, this root is beta. A number k lies in between, somewhere in between alpha and beta. This graph is cut x-axis at 2 times, so d is greater than 0. Okay. Then only a number would be in between alpha and beta, so d is greater than 0. Second, check value of function equation at k. Fk is always greater than 0. Sorry, Fk is always less than 0. Fk is always less than 0. Means value of this equation Fk will be less than 0. Means ak square plus bk plus c is less than 0. D is greater than 0 and ak square plus bk plus c is less than 0. These two equations, these two inequalities are the basic conditions of this. So find condition when a number lies between two roots of ax square plus bx plus c, then d will be greater than 0 and ak square plus bk plus c, or fk is less than 0. Okay. Like question, if a number 6 lies between x square minus ax plus 4 equal to 0, lie between roots of x square minus ax plus 4 equal to 0, find range of a. Find range of a. So alpha, beta, here is any number 6. So first condition, d is greater than 0. D is greater than 0 means a square minus 16 is greater than 0. Means a minus 4, a plus 4 should be greater than 0. Means 4 minus 4 means a is greater than 4 or a is less than minus 4. Now second condition, f of 6 is less than 0. F of 6 means 6 square minus a into 6 plus 4 is less than 0. 36 plus 4 minus 6a is less than 0. Means 40 minus 6a is less than 0. Means 6a minus 40 is greater than 0. Means a is greater than 40 by 6. Okay. So 4 minus 4 and 40 by 6. This is greater than 40 by 6. This is greater than 4. This is so intersection of this is 40 by 6. So a should be greater than 40 by 6 is our answer. Okay, a number 6 lie between roots of this, find range of it, alpha comma beta 6, d is greater than 0 and value of function at x is equal to 6 will be greater than 0. Now this is clear now. Case 2. Find condition when a number k exceeds two roots of equation. Exceeds two roots of equation ax square plus bx plus equal to 0. Find condition when a number k exceeds two roots of equation. This is alpha, this is beta. A number exceeds means first condition d is greater than 0 and value of function at k, f is equal to k, fk is greater than 0. Solve these two equations and find intersection and find any range or like any condition in a, b, c or n. D is greater than 0 and fk is less than 0. Case third, find condition when a number k is less than two roots of the equation. Case third, find condition when a number is less than the number k is less than the roots of equation. ठीक है. Same case, alpha comma beta, a number k is less than that, so d is greater than 0 and value of function fk is also greater than 0. So case 2, find condition when a number k exceeds two roots of the equation, and case third, when a number is less than two roots of the equation. So d is greater than 0 and fk is greater than 0. Case 4, when two roots of equation lie between any two numbers, two roots of equation alpha comma beta lie between any two numbers. Let this number is k1 and this number is k2. So condition, first condition, d is greater than 0. Second condition, value of function at k1 is greater than 0 and value of function at k2 is greater than 0. So f k1 is greater than 0 and f k2 is greater than 0. We will solve these three equations and find intersection and our answer. Any form like range or something like that. Okay, when two roots of equation lie between any two numbers. So these are our basic conditions. If you know how to draw a graph, then these are very easy. Now if you want to find the maximum and minimum value of a quadratic equations or quadratic equations written in P by Q form. Maximum and minimum value of equation. Maximum or minimum value of quadratic. Okay. Maximum and minimum value quadratic means let y is equal to x square plus 2x plus 3. We want to find the maximum and minimum value of this function when x is real. X is real. X is real means d of when we will form a quadratic in x, then d will be greater than or equal to 0. Because we have three conditions in D. When D is greater than 0, roots are real and equal. When D is equal to 0, roots are real and equal. When D is less than 0, roots are complex and unequal. So we have two conditions when x is real, means when D is greater than 0 or D equal to 0. So D is greater than equal to 0. Now make quadratic 2x plus 3 minus y equal to 2. Here x is real. So d will be greater than equal to 0. So db square minus 4ac should be greater than equal to 0. Means 4 minus 4 into 1 into 3 minus y should be greater than 0. And 4 minus 12 plus 4y should be greater than 0. Means 4y should be greater than 8. Means y should be greater than equal to 2. So minimum value of this function will be 2 and maximum value will be infinity. We just learn a method that minimum value of this is y minimum will be minus b by 4a minus b square minus 4ac divided by 4 minus 4 minus 12 divided by 4 is equal to minus 8 by 4 is equal to 2. So minimum value of is 2 and maximum value will be infinity. Another method, x square plus 2x plus 1 plus 2, so x plus 1 whole square plus 2. This value will be, minimum value of this will be 0. So 0 plus 2 is equal to 2. So minimum value of this will be 2 and maximum will be 3. Okay. So this method is applicable for any number. This method is applicable for when a number is written in p by q form, like y is equal to x square plus x plus 1 divided by x square plus x plus 2. We want to find maximum and minimum value of this y when x is real. We want to find maximum and minimum value of this when x is real. X is real means when we will form quadratic in x where b is greater than equal to 0. So just cross multiply this. Yx square plus yx plus 2y is equal to x square plus x plus 1. So x square y minus 1 plus x y minus 1 plus 2y minus 1 equal to 0. Here x is real, so b will be greater than equal to 0. So y minus 1 whole square minus 4y minus 1, 2y minus 1 is greater than equal to 0. So y minus 1 minus 4 into 2y minus 1 greater than equal to 0. So y minus 1 minus 8y plus 4 is greater than equal to 0. So y minus 1 minus 7y plus 3 is greater than equal to 0. So y minus 1 7y minus 3 is less than equal to 0. So 1 and 3 by 7. So minimum value y minimum is equal to 3 by 7 and y maximum will be just cross multiply this and make quadratic in x, and x is real, so b is greater than 0 and solve this inequality. So y minimum is equal to 3 by 7 and y maximum is equal to 1. Like we want to find y is equal to x square minus 3x plus 4 divided by x square plus 3x plus 4 where x is real, and we want to find the value of minimum value and maximum value of y. Just cross multiply yx square plus 3yx plus 4y is equal to x square minus 3x plus 4. So x square y minus 1 plus x 3y plus 3 plus 4y minus 4 equal to 0. So d is greater than equal to 0. So 3y plus 3 whole square minus 4y minus 1 4y minus 4 is greater than equal to 0. So 9y square plus 9 plus 18y minus 4y square minus 4y minus 4y plus 4 is greater than equal to 0. So 9y square plus 18y plus 9 minus 16y square plus 32y minus 16 is equal to 0. So minus 7y square plus 50y minus 7 is greater than equal to 0. And 7y square minus 50y plus 7 is less than equal to 0. So 7y square minus 50y plus 7 is less than equal to 0. So 7y square minus 49y minus y plus 7 is less than equal to 0. So 7y minus 7 minus 1y minus 7 is less than 0. So 7y minus 1 and y minus 7 is less than equal to 0. So 7 and 1 by 7. So minimum value will be 1 by 7 and maximum value will be 7. So this is the process to find maximum and minimum value of a quadratic function or quadratic equation. Okay. Now transformation of equations. Transformation of equations. Transformation of equations. Transformation of equation. Transformation equations means we will find second equation with the help of first equation. Like we have given ax square plus bx plus c equal to 0 has roots alpha comma beta, and we want to find any equation whose roots are reciprocal of this, means roots are 1 upon alpha and 1 upon beta. Okay? We know that our basic equation is x square minus sum of root into x plus product of roots is equal to 0. So basically to form an equation we need sum of roots and product of roots. Same we could apply here, x square minus sum of roots into x plus product of roots is equal to 0. So x square minus alpha plus beta divided by alpha beta into x plus 1 upon alpha beta is equal to 0. So x square minus alpha plus beta minus b by a, c by a plus 1 upon c by a equal to 0. So x square plus b by c plus 1 upon a by c equal to 0. So cx square plus bx plus a equal to 0. This is equation whose roots are reciprocal of first equation. We could do it directly by just replacing x by 1 by x. A 1 by x whole square plus b 1 by x plus c equal to 0. Cx square plus bx plus a equal to 0. Okay, just replace x by 1 by x. So this equation will form whose roots are reciprocal of the first equation roots. Now just the extension of this. Like x square plus 5x plus 6 is equal to 0 minus 5x plus 6 is equal to 0. So x is equal to 3 and x is equal to 2. Roots are 3 and 2. Now we want to find an equation whose roots are square of this root. It means we want to find an equation whose roots are 4 and 9. So equation will be x square minus 13x plus 36 is equal to 0. This is one method. Other method is we want to find the roots equation whose roots are square of this. So just follow the reverse operation. Reverse operation means we want roots square of this, so replace x by root over of x. Square root x means if we want cube of this root means 27 and 8. So replace x by x to the power 1 by 3. So just apply reverse operation. Like we replace x by root x. Root x whole square minus 5 root x plus 6 is equal to 0. So x plus 6 is equal to 5 root x. So x square plus 36 plus 12x should be equal to 25x. So x square minus 13x plus 36 is equal to 0. So just apply reverse operation. If we want any equation whose roots are some cube of this root, whose roots are cube of this root, so just replace x by x to the power 1 by 3. If we want any equation whose roots are cube root of this, so just replace x by x. You just follow reverse operation of anything we want to find. Like we want to find root 3 plus k and 2 plus k. We want to find equations whose roots are 3 plus k and 2 plus k. So just replace x by x minus k and okay, just reverse operation. 3 plus k, 2 plus k, here we added k. So just subtract k in x. So x replace x by x minus k. Or we want to find 3 minus k, 2 minus k, so replace x by x plus k. So we just follow reverse operation here. So this is known as transformation of equations. Like any equation ax square plus bx plus c, ax cube plus bx square plus cx plus d equal to 0. And any equation given ax cube plus bx square plus cx plus d equal to 0 has roots alpha, beta, gamma which are in AP. These roots are in AP and we want to find an equation whose roots are in HP. These roots are in AP and we want to find an equation whose roots are in HP. AP is just reverse of HP, so we just want to find equations whose roots are 1 upon alpha, 1 upon beta and 1 upon gamma. So we want the reciprocal of these roots. So just replace x by 1 by x. We will replace x by 1 by x and equation will form that will be reciprocal, whose roots are will be reciprocal of the alpha, beta and gamma. Equation will be like a by x cube plus b by x square plus c by x plus d equal to 0. So dx cube plus dx square plus dx plus a equal to 0. This is equation whose roots are in HP. 1 upon alpha, 1 upon beta, 1 upon gamma and 1 upon alpha, 1 upon beta and 1 upon gamma. Okay, this is known as transformation of equations. We just follow the reverse operation here. If we want to find any equation whose roots are square of this, just replace x by square root. If we want any equation whose roots are reciprocal of this, just replace x by 1 by x. If we want any equation whose roots are cube root of x, just replace x by cube of x. So these are basic things. Theory of equations and transformation of equation. This is known as transformation of equation. So this is it for today's session.